So, hello everybody. Good afternoon. So my classes continue. I still remain with you today, bringing you the live solvents, granting you great knowledge, information on differential calculus. Sorry about all that adjusting. We are back again, and we are grateful to God for another day. You know, we say half results means you put in half efforts. But actually, half efforts does not produce half results. It produces no results at all because half effort is not good enough. So when we start something, we must be at it and keep at it. Alright? So that's why we're here again. Grateful to God. Now we started differential calculus the last time and we talked about from first principles. So progressing from that is where we are right now. From first principles, we go to these topics that find the derivatives of each of the following. There are different questions here, and each of these questions deals with a different way that differentiation can be done. So that's the reason why I just picked these different top questions. I just picked them to use it to identify what we need to do. Is that okay? So we just did that. I just did that to identify so I will not be going back and forth. Okay, so the first question, y equals to minus 2 over 3 x raised to power 4. Now the basic rule, this one identifies the basic rule, which is axn. The differential of it, which is dy, that's y, dy over dx of it, is you put n minus 1 and n minus 1, you bring the n to the fourth multiplied by ax n minus 1. So this gives us the answer. For every time n, for every x that we are looking for, you minus 1, and then the value that was there used to multiply the value at the front. The value on top used to multiply the value at the front, and then you remove 1 from that value, whatever the value is. So using that in this question, we have dy over dx, therefore, is equal to 4 comes to the front, multiply minus 2 over 3x, 4 minus 1. So 4 times minus 2 is minus 8 over 3 x raised to power 3. That is the dy over dx of A. Now we go to B. Okay? B says 3x2 plus 1 over x. So how do we solve this? In differential, what we do is that we do one and the other. So this is differential of a sum. And how do we do the differential of a sum? Is that we do it individually, just like we did this. We'll do it for this and do it for this. So we'll do it individually. So naturally, we can rewrite this 1 over x to make it in a way that can be easily understood. So we say, naturally it's y always. 3x2 plus 1 over x is same thing as x raised to power minus 1. X raised to power minus 1. Same thing as 1 all over x. Is that okay? Anything raised to power 1 over x is same thing as 1 x raised to power minus 1. So therefore the differential of it is now these two. Take note, the 2 is with the x. Comes to the front to multiply 3. This time gives us 6. 2 minus 1 disappears. And this minus comes to the front to be minus 1 multiplied by x. Minus 1 gives us now minus 2. So this rewriting it gives us 6x minus x raised to the power minus 2. Now, x raised to the power minus, anything raised to the power minus gives us the inverse. The inverse of it is now the correct one. So this is same thing as saying 6x minus 1 all over x raised to the power 2. So that's just how it is. That's how it is. So the sum rule, you what? Differentiate them individually, which is what I've just done. So this is the differential of this value. Okay? It's true any day, anytime. It remains true any day, anytime. The third one is a bit tricky. Now, here it is what we call, this is a value inside another one. So we apply what we call the chain rule. So this one applies what we call the chain rule. So this is where we are starting from today. The chain rule. What is it about? The chain rule means that whatever is inside another value, you first of all differentiate it individually. That's from the top, and before you now differentiate the one inside. So you differentiate the top and you differentiate the one inside. What's the rule for chain rule? Chain rule is that whatever value we have, dy over the x of it is that we have dy over du times du over dx. When u is a value that is made up from what? Dy. That's a value that is coined up from dy, that makes it dy easier to resolve. What do we mean is that now in this situation now u is equal to 6 minus x squared. Why did we choose 6 minus x squared? Because when we do that, it makes it easier for us to resolve it. Okay? Makes it easier for us to resolve it. Therefore, we are now saying y is equal to 5 all over u raised to the power 3. You see now this is, before we're having a complex variable in which this one was so hard to resolve. But now that it is like this, becomes easier. This is why u. That's why dy over du is there. And then u, when you say u is equal to 6 minus x squared. So what we do is that we differentiate u with respect to x. Differentiating that, the 6 disappears. It's now minus 2x. Is that also? And then dy over du, differentiating this. Remember, this is something as 5 u raised to the power minus 3. Okay, I'm only rewriting it. So dy over du is equal to minus 3. It's now minus 15. How we said it? U minus 3 minus 1 is minus 4. Okay, so rewriting this is saying minus 15 all over u raised to the power 4. Now applying the rule, we said dy over dx is equal to dy over du. What's dy over du? Minus 15 all over u raised to the power 4 multiplied by du over dx. Du over dx is what? Minus 2x. Take note, the du cancels itself out to give you dy over dx. If it doesn't cancel itself out, you know what you are doing is wrong. This is the rule, the chain rule. So no matter the amount of figures that you want to create, they must all cancel themselves out. What I mean with that is that if you want to add a v, okay, so dy over dx will be equals to dy. The last one you deal with is the one that comes up, dv times dv over du times du over dx. Are you seeing it? So if it was that there were 3 that were inside, then let's say, for example, everything here, we now put a bracket again and put squared all over another value, and you see that even inside the v, the u would have not had to do another dv. Are you getting it? Then we'll now compute values. Is what would have given us. So as long as it purpose, but you find out that this, when you cancel this out, du cancels du, dv cancels dv, gives us dy over dx. There's the idea of the chain rule. The chain rule must always bring us back to dy over dx. Very important. Never miss that. Remember, we are replacing the u as 6 minus x squared. So the final answer is minus 15 all over 6 minus x squared raised to power 4 times minus 2x. So if we minus times it gives us 30x. Let's save ourselves the stress. Remember, it was minus times minus plus 50 times 2 is 30. X times 1 is x. So this is our final answer. Is that okay? Are we following thus far? I think we're doing well.